back. Since this is another video, I want to make sure that you understand a couple of things about my video solutions. It is not okay to come here with a blank piece of paper and copy these answers or these solutions so that you can walk into your class tomorrow and think you're a genius and make your teacher seem, oh my God, look at me, I'm so smart. Please use these appropriately. I don't make these videos so you can sit here and copy and not help you in class. I want to help you. I want you to be successful in what you're doing, not cheat. So if you're using these to cheat, you're just fooling yourself, because that test is hard. And you have to work at it. If you work at it, you can do it. And I'm going to teach you a lot of stuff as we go through these video solutions on how to improve on what you're doing so that you can be successful. But if you're cheating, you're not going to help yourself. If you like what you see, please hit the subscribe button. I'm trying to get to 500 subscribers. If you don't like it, hit the subscribe button. Anybody, hit the subscribe button anyway, and I'll just annoy you week after week every time I post a video. Just kidding. Anyway, hopefully you're here to work with New York State Algebra 2 Trigonometry Regents exams. That's what I'm here to do. This is June 2010, Part 1, Problems 15 through 27. And I'm breaking them down into 3 videos. Part 1, the multiple choice, I'll break down into 2 sections, and then I'll do the extended response as 1 section as well. So, hey, here we go. So, we are on 15. If this is not where you want to start, go find the other video. And, yeah. Hopefully I'm going to be smart enough to put these in the show notes that you can go from one video to the next, to the next, to the next. We'll see. So let's see what we got here. We got this strange problem with all this craziness here. I'm going to show you two ways to do this problem. Clearly, I want to show you the math way, so we'll start with that. So what we have here is 4, hold on, I got the wrong pen, to the x squared plus 4x equals 2 to the negative 6. Well, let me ask you a question. Let's go back and do a little review. If I had x to the 5th here equals x to the, let's say, y, just for fun. What's y? Since these bases are the same, wouldn't you say, oh yeah, y is 5? So as long as the bases are the same, you can set the exponents equal to each other. So that's what we're going to do, is we're going to convert this 4 into something that looks like this. Well, isn't 4 really just 2 squared? And then so you get 2 squared times x squared plus 4x has to equal 2 to the negative 6. Okay, so now that the base is the same, really all we have to do is take the exponents and set them equal to each other. And I'll do that right now, but I need a little room. Let me get rid of all this stuff. So I'm going to set those exponents equal to each other. So I get, oh, and while I do this, I might as well distribute, because I'm going to have to distribute here anyway. So I end up with 2x squared plus 8x equals negative 6. I'm going to bring that negative 6 over, so I get 2x squared plus 8x plus 6 equals 0. They have a GCF of 2. Let's make my life easier. Take out this 2. I'm left with x squared plus 8. Oops. Brain fart. 4x plus 3 equals 0. And I'll factor this. And this will be a good opportunity for me to show you many different ways. Man, I'm going to show you some really cool stuff on this one. This gives me x plus 3, x plus 1. They multiply to 3. I do not do any other method than guess and check. They multiply to 3 and they add up to 4. So my two answers are x equals negative 3 and x equals negative 1. So there's the first solution, negative 3 and negative 1, the choice 3. That's one way to do the problem. That's one way to do a problem. Let me show you something else. Let me show you another way to do the problem. What I'm going to do, I don't know why I'm erasing this. What I'm going to do is, I see 1s and 3s, so what I'm going to do is I'm going to go to my calculator. Oh, well, you have to have gotten, no you don't. I'm just going to type both those sides in. So let's see if I can bring my calculator up. I'm going to be looking over my screen so I get this right, so you can look back. So this side was Well, the first thing I'm going to do is take the first answer, which is 1, and I'm going to store it into x. So now anytime I hit x, it's really just a 1. And I'm going to check to see if 1 is an answer. If 1's not an answer, I can eliminate choices 1 and 4. Let's see. So how am I going to do this? I'm going to do 4 raised to the x squared plus 4x. X squared plus 4x equals, oops, I don't know why I had a space, equals 1024. And then I'm going to go to the other side, and I'm going to do 2 raised to the negative 6, which is clearly not going to be 1020. 1/64. Ain't the same thing. 1 is not an answer, so what I can do is I can eliminate choice 1 because it has a 1, and I can also eliminate choice 4 because it has a 1. Now I know this is the answer. Now I know negative 1 works because there it is. And I also know that this one's the right answer. So I'm just going to go right to that. And let's try this. Now, beauty is I've already typed this in. So now what I'm going to do is I'm going to take negative 1 and I'm going to store it into x. And then I'm going to hit enter. But I don't want to retype that stuff. So I'm just going to go up to this. I already know it's got to be negative 1 or 1/64. I'll type this in. I'll hit enter. Oh, look, 1/64. And doesn't that match 2 to the negative 6? So negative 1 works. Let me just make sure negative 3 works. Negative 3, control var x, and I'll hit enter. And this should also be 1/64. There it is. Now, that's method 2 to solve this question. Let's go back. If you remember correctly, we had a quadratic. I'll find my pen. We had a quadratic that was 2x squared plus 8x plus 6 equals 0, and I just factored that. Now, some of you hate to factor. Hate. So let me show you something you can do on the calculator. I'll probably put a little video on this one. Let me get rid of all my history. I like to get rid of history every once in a while. So what we're going to do is we're going to go into menu. This is algebra. And we're going to go and work into polynomials. And we're going to find roots of polynomials. Believe it or not, this will find the roots for you. It's a second degree polynomial. That means it's quadratic. And we want to find the real answers. And my choices were 2, 8, and 6, I believe, right? I hit enter. Was that my quadratic? 2x squared plus 8x plus 6? I believe so. The answers are negative 1 and negative 3. And there is another way to get to your solutions. Okay, so clearly that's the right answer. All right, let's go to this next problem. So here I have an x squared and a y squared. That's a circle. I know it's a circle. It's got to be a circle. But that's not how we're doing the problem. What we want here is we're going to solve this by completing the square. And some of you that you don't remember that, but what we're going to do is we're going to put the x numbers together. And I'm going to leave a little space here. Now we're going to put the y stuff together. Y squared plus 6y and a space. And we're going to send that 3 over to the other side. So, if you remember completing the square, you take half of this and square it. Well, half of negative 2 is negative 1. Negative 1 squared is positive 1. Well, if I add plus 1 there, I got to come over here and add plus 1. And if you remember correctly, this parentheses will be x minus 1 squared. It's whatever half of this is. Goes in here. X minus 1 squared. Then we're going to go to this one. Well, what's half of 6 squared? That's positive 9. Positive 9. And so this parentheses will be y plus, what's half of 6? 3. You got it. Y plus 3 squared. This plus should be here. Oh, look. Dang. Both there. So, but I added 9. So this adds up to 10 minus 3 is 7. And there's our answer. Done. Oh, you want another way to solve this problem? You want to know for sure if you got this correct? Because you're that person that wants to make sure you don't make any stupid mistakes. Well, this is time consuming. If you don't want to know how to do this, fast forward. If you do, don't fast forward. Let's pick a number. I don't like to pick 0 or 1, so I like to pick 2 or 5. And if it doesn't work out, I pick a different number. So I'm going to try 5. So I'm going to say, okay, 5 store it into x. And I want to know if I got the right answer. So I'm going to type in the original. Oh, I got to use y too. So let me get something in for y. Let's take 2 and store it in for y. Where's y? Y. So my original one was x squared. So x squared plus y squared minus 2x plus 6y plus 3. 34. Now let's type in my choice, which was parenthesis x minus 1 parenthesis squared plus parenthesis y plus 3 parenthesis squared. And then we want to make sure this said equal to 7. So if I bring that over, minus 7, this should be 34 as well. And there it is, 34. Perfect! Because it said equal to 7, but I had to bring that to the other side. There we go. My answer matches the final answer. All right, going off to the next page. Try to show you how to use this as well. All right. So, got a few things going on here, kids. A couple easy ways to check this, and there's a couple hard ways to check this. So let's see what we got. Well, I got to get rid of my eraser. So I'm going to just solve for y. So I get y is greater than or equal to x squared minus x minus 6. Now, if you're greater than or equal to, if I give you some graph and you want to go greater than that graph, wouldn't you be up here? You wouldn't really be down in here, right? So we're really looking for the one that's greater than this or above this. So I'm going to assume then that these over here are not solutions. Not a solution. Not a solution. Because those are below the graph. And since this says the y's have to be above the graph, that's the one. Now, what's the difference between these two? The difference between these two are the roots. That's a negative 2, and that's a positive 3. This is a negative 3, and that's a positive 2. So it looks as if we need to figure out how to factor this thing. So x and x, they have to multiply to negative 6 and add up to negative 1. Well, that's negative 3 and positive 2, which means my roots are x equals positive 3 and x equals negative 2. So I need the one that has a positive 3 and negative 2, and that is choice 1. Now I can also come over here and graph this puppy. If I can find my graphing calculator, there it is. Go into graph mode. We'll graph this thing. And I want to graph, well, here, let's delete this, and I'm going to choose greater than or equal to. Y is greater than or equal to, and let's see, it was x squared. So yes, you can do that on this calculator. X squared minus x minus 6. And if I graph it, notice my roots. Positive 3, negative 2. Notice it's showing above. There we go. We know we got the right answer. Bam, there it is. All right, moving on. Anytime you see a square root in an equation, you know you're going to be squaring it to get rid of it. So what I have here is the square root of x plus 3 equals 3 minus x. So I know that I need to square this side. And I also need to square this entire side. And the key is being able to put that in parentheses. Now, if you're one of those kids that make me so angry, that you would say this is 3 squared, or 9, minus x squared. Oh, God, that drives me crazy. You get x plus 3 equals, this one you have to double distribute. 3 minus x. So, this is 9 minus 3x minus 3x plus x squared. So, Never want to leave your x, always want to leave your x squared positive, so these things are coming over. Let me clean this up a little bit. X squared minus 6x plus 9. Just going to kind of clean up that side. I end up subtracting this x and subtracting this 3. So I get 0 is equal to x squared minus 7x plus 6. And if I factor this, I get x minus 1, x minus 6. And my two answers are x equals 1 and x equals 6. Check everything. Everything must be checked. Do not be lazy. Go through all of this work and check it. Not only that, I wouldn't even probably do this question this way since I can do these all backwards. Yeah, I'm going to check my answers. My two answers are 1 and 6. So I'm going to come over to my calculator, and you can do this on any calculator. Maybe you can't use the stow feature. Most calculators have stow feature. And I'm going to do, okay, 1 stow x. Enter. And then I'm going to type in the square root of 1, or no, excuse me, x plus 3. And hit enter. 2. And then I'm going to do 3 minus x. Oh yeah, I just did that. 2. Oh yeah, I did. That's right. Perfect. 1 is an answer. So now what I'm going to do is I'm going to, my other answer was 6. So 6 stow x. And then I'm going to save myself a little bit of time. I'm going to come up here, and I get enter, enter 3. That's the square root of x. And then I got to do 3 minus x. Ooh, negative 3. Wow. Didn't know that was going to happen. So this is what's called an extraneous root. It is not a solution. The answer is choice 1. Check your answers, kids. I cannot stress that enough. Only lazy kids don't stress their answers, and you don't want to be lazy. The world does not need any more lazy people. Oh yeah, I'm going to show you 2 ways to do this problem. The cool way and the cooler way. It's math. There's only cool and cooler. There's nothing in between. There's no in between. I teach my kids the I circle. The I circle will come in handy in your, if it's a part 2 question. So let's talk about this. I to the 1 is just I. That's easy. I to the 2 is negative 1. Now if you remember those two, the others are just opposites. So down here I've got I to the 3 is negative I. It's just the opposite of up there. And I to the 4, and this is the key one, I to the 4 is 1. So these two are, they're all key, I guess. So let's see. I want to take the product. Product means multiply. So I'm going to multiply these two things together. So I to the 12th. When you multiply things that have the same base, you add the exponents. Now, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's your answer. I to the 12th is the same as I to the 4th. Because every I to the 4th is a 1. 1 times 1 times 1 times 1 is 1. So the answer is choice 1. Ka-ching! The right answer. Now, that's that. Now, let's go down, find my mouse. I could also cheat. Control, we'll click on I, we'll raise I to the 7th power, we'll multiply that times I, raised to the 5th power, hit enter, 1, finished, done. Second way to do the problem. There it is, finished. Have I driven up enough point that you probably should be getting this calculator? Probably. Oh, not able to scroll again. Hate it when that happens. Oh yeah. There we go. Alright. Oh man, we haven't done these in my class yet. But it's not even, it's just March. Spring break. Oh, I'm on spring break, by the way, working. Oh, so here's what you want to do on these. Make sure I have red. We're going to use these points. And we're going to graph these points. And I want to graph, it's trig. So, and in between those 2 points, since those are max and mins, are probably 0. So what I'm going to do is I'm going to graph this function. So what I just graphed there was, if you can see it, maybe see it better like this, that's the cosine curve. Starts at a max, ends at a max. The graph that rides on the top of the humps of the cosine curve or the bottom of the humps of the cosine curves is the co-function, excuse me, so we know that secant theta, or x or whatever, is equal to 1 over cosine theta. So the ones that ride on these are not the cofunctions, I almost said that, are the reciprocal functions. And secant theta is the reciprocal function of 1 over cosine, which means when you graph it, it rides on top of or on the bottom of the cosine curve. And there we go. That problem's over with. Woohoo! Yay! All right. So our value is the correlation coefficient. We're trying to figure out which correlation coefficient gives us the strong negative linear correlation. Well, here's the first thing you got to know. It can't be bigger than 1. Correlation coefficients run between -1 and +1. Very strong, very strong. If it's somewhere near 0, weak. So, strong positive, I just wrote strap, strong, and strong negative. And we want a strong negative, so our strongest negative correlation coefficient is this one. This would be the strongest linear relationship. This one right here would be the strongest, but it's the strongest positive and can't be. Therefore, the answer is 2. Moving on. Choice 9. All right. In order for inverse functions to be a function, in order for inverses to be a function, the original function must pass the vertical line test and the horizontal line test. Well, by now you should have graphed the tangent curve. By now you should know that the tangent curve runs between -pi over 2 and pi over 2, and it runs something like this. But it runs as a continuous pattern like that. So every pi over 2, or every pi distance, we will have it looking like this. Well, if I can keep going in either direction like this, it will always pass the vertical line test, but you can clearly see that it fails the horizontal line test. So I have to get rid of this, and I have to get rid of this. And if I just have this centerpiece, then that would be a function that passes both the vertical and horizontal line test. And that's from -pi over 2 to pi over 2. And that's why that's your answer. What is the measure of angle K? Well, you can do this 2 ways. You can use, I don't know if you guys learned Sokotoa, some old horse caught another horse taking oats away, or some old hippie caught another hippie tripping on acid, or some old hoe caught, we won't go there. Anyway, you could use that, or you can use the law of cosines. I don't really care. I'm going to show you both. I'll show you both. So the sine of K is equal to opposite, wait, why am I doing sine? This is the hypotenuse, and this is the adjacent side. See, that means I got to use cosine. Sometimes that gets confusing. So cosine is equal to 5 over 6. Or in order to find x or k, you have to do anytime you're looking for an angle. Anytime you're looking for an angle. I don't care what it is you're doing. You're going to be doing inverse trig. Cosine inverse, sine inverse, or tangent inverse. In this case, it's cosine inverse. So cosine inverse of 5 over 6. Done. Come to my calculator, and I'm going to do inverse cosine of 5 divided by 6. Bam! There it is. Now, the question also said to the nearest minute, I believe. So I got to go into this book. You got to find your... I don't have a TI-84 emulator. You got to go to your book and you got to scroll up and down until you find DMS. DMS is degrees, minutes, seconds. Hit that. You DMS it. It's a verb in math. And you get 33, 33, 26. So this is degrees, minutes, and seconds. We want degrees and minutes, so it's 33, 33. Now, if you don't like that method, or you always forget, or which way is SOHCAHTOA, whatever it is, you can always use the law of sines. And remember, the law of sines says you're going to take a side over its angle, and a side, oh man, can't really do the law of sines here until we do, well, the only way I'd be able to use the law of sines here is if I went through and found this. Because really what I want is that over that. Well, that's not true. I could use the law of sines, but I would have to find this angle first. So I would have to do 6 over the sine of 90 equals 5 over the sine of W. And let me finish this. 5 times the sine of 90 equals 6 sine W. And then divide by 6, divide by 6. By the way, just in case you're wondering, the sine of 90 is 1. And if you type this in your calculator, which I'm not going to because it's kind of a waste of time, I get the sine of W equals 5 over 6. And if I do that in my calculator, I go, okay, inverse sine of 5 divided by 6. Notice it's not cosine this time. I get 56.44 degrees. Now, if I want to find out what the other angle is, I'll take 180 and I'll subtract off this angle. And I have to subtract off the 90. I forgot to subtract off the 90. And subtract off the 90. That will tell me the remaining angle is 33.55. And then I DMS it, and I get my 33.33 that way. Kind of a pain in that case, but it's not bad. You can always use the law of cosines. Here we go again. Oh, crap. What page was I on? Oh, I'm on this page. I don't know why it keeps doing that, stupid computer. All right. I think I got 2 methods for you on this one. I think I got 2 methods for you. Oh! I don't know. Are you guys as dumb as some of my kids? Because I tell my kids, I love my kids. I do. I really do. I have some amazing students this year. Just awesome kids. I can't possibly be any happier with my kids, except for the dumb ones. Which is a lot of them periodically. They forget that New York State gives them a reference sheet. And no matter how, when I look at my reference sheet, I drink Brugger's coffee. Amazing stuff. Anyway, I give them a reference sheet, and I tell them anytime you see a double angle, a 2 theta, you are going to be popping over to your formula sheet and looking for it. Now, cosine gives you 3 different options. Let's go back. I only have this and this. So the only other thing in my problem is a cosine. So I want to pick the one that just has cosine. 2 cosine squared theta minus 1. I want to pick this one. Not sine. I don't want to introduce any other sine. I want to just pick the one that is associated with what I already have. So it's 2 cosine squared theta minus 1. So I'm going to write that down if I can find my pen. So I've got cosine squared theta. Now here's the trick. Minus, you're replacing it, put in parentheses when you replace things, 2 cosine squared theta minus 1. Well, now I got to distribute this minus, so I get cosine squared theta minus 2 cosine squared theta plus 1. And you already see that the answer is, in fact, oh man, this is a pain in my neck. So this is negative 2 cosine squared theta plus 1. Not negative 2, negative 1. 1 minus 2 is negative 1. So it should be negative 1 cosine squared theta, or just negative cosine squared theta. Well, that's not up there. You may really want to pick this one, or really want to pick this one, but those are not the right answers. So, therefore, you have to remember something else that's not going to be on your formula sheet, and that is cosine squared theta plus sine squared theta equals 1. And if I bring this over here, isn't this sine squared theta equals 1 minus cosine squared theta? And can't this be written as 1 minus cosine squared theta? It can, and it is. And so the answer is sine squared theta, choice 1. But let's see if there's another way to do this one. I wonder if there is. I believe there is. Let's try using a calculator. I'll bet there's a way to do this using a calculator. Let me get rid of all this crap. Get a fresh screen. It was cosine squared, so let's do parentheses. Cosine of 30 squared minus the cosine of 2 times 30 equals 0.25. And then I'll do parentheses, trig, sine of 30 squared. Oh, I did times 2. That was dumb. Maybe it looked like I got the wrong answer. I didn't get the wrong answer. I just did the wrong word. Squared. 0.25. 0.25, 0.25. There they are. They match. Another way to check. Now, if you don't like that and you like the way they wrote it, I think you can do it this way. You just got to be careful with cosine squared. I'm not really sure how this is going to work. Will they let you put a square? I think they will. Cosine squared 30. And you could put it in like this. I think this calculator will allow this. Minus cosine. I am freezing. It's spring break and it's like 10 degrees outside. Gotta love New York State. But, see. Yeah, it doesn't like this. It doesn't like this. In order to put it in cosine squared, you have to actually do cosine and then square the whole thing. I kind of thought that might crash. I haven't done that in a long time. I forgot. Alright, moving on. Just another way to test it. Oh my goodness. I love sigmas. Not really. So how do I want to solve these? Well, let's see what we got here. Let's make k negative 1. If k is negative 1, and I don't know, which one do we want to start with? This one looks good. K is negative 1. Negative 1 plus 2 is 1. These are odd, all the odd numbers. I don't want to make sure I get the odd numbers. And then if k is 0, I get, so this is when k equals negative 1. And then when k equals 0, I get 2. That ain't going to work. And let's try this one. When k is 1, I get 2 times k, which is 2 minus 1, which is 1. Perfect. And then when I get k is 2, if I say k is 2, that's 4 minus 1, which is 3. Perfect. And I say k is 3, I do 2 times 3, which is 6. 6 minus 1 is 5. Oh my god, this has to be the right answer. So I better check the end. I checked the beginnings, I better check the end. Let's try 39. 2 times 39 is 78. 78 minus 1 is 77. Last number 77? No, it's 39. Way, way, way too much. Now let's start with 2. K is 2. 2 minus 1 is 1. Perfect. Let's do 3. 3 minus 1 is 2. Nope. That's why this is the right answer. It's basically this exact same thing, but when I check the end there, 2 times 20 is 40. 40 minus 1 is 39, and that gives me my last value. Choice 1. So this is a geometric sequence, because you can know it's a geometric sequence. It's coming down, and the numbers aren't the same that it's coming down. If I figure out what do I have to do to 54 to get to 18, or maybe even easier, what do I have to do to 18 to get to 6? And if you look at the answers, they kind of give it to you. See the 1/3s all over the place? Right? There they are. So what we're going to do, the way it works is a sub n is equal to a sub 0, your first number, which in this case is 54. And then we're going to have the multiplier, 1/3 to some exponent. That's just how it works. Hopefully your teacher taught this to you. How are we going to do this? Well, I don't know. Let's see. Did I just switch pages? I hope I didn't switch pages. So it's going to be a sub n is equal to 54 times 1/3 to some exponent. So let's say a is 1. Well, that means 54 times 1/3 to the 1. 1/3 to the 1 is just 1/3. So that means a sub n would be equal to 18. But I really want, yeah. Well, and this is remember, this is a sub 0. So if a was 0, 0, no, I just screwed something up. Hold on a second. I'm sorry. I think I misspoke. I want to make sure I re-speak properly. Let me get rid of all this crap. So we know that the first term, a sub 1, we know that the first term, a sub 1, this is a sub 1, this is a sub 2, a sub 3. So I want to make sure that a sub 1 gives me 54. So this is the right answer, by the way. If I type this in, and I start with 54, 1/3 to the 1 minus 1. Well, this gives me 0 as an exponent. And 0 as an exponent makes whatever it is you're raising to that 0 a 1. So this becomes 54 times 1, which is 0. If I did it over here, this would be 54 times 1/3 to the 1. And that would actually only give me 18. So it would not yield this as my first number. And because of that, it can't be the right answer. Choice 4. And finally, the last multiple choice question. Oh, and we end with an easy one. Well, sort of an easy one. You have to remember that period is defined as 2 pi over b. This is A, this is B, this is C, and D is over here, but it's missing. So in this case, it's, well, I'm going to need some room. It's 2 pi over, now, man, these guys were not nice to you guys. Okay, so really what this is it's a 1/3 x. So x is our angle. It really should be there if they wanted to be nice to you, but of course they want to end the multiple choice just by, yeah, man, giving it to you. Yeah. So in this case, b is really 1/3. Really 1/3 is b. Now, if you divide by a fraction, it's really like multiplying by the reciprocal. So this is really 2 pi over 1 times, and we're going to multiply by the reciprocal, 3 over 1, and this takes 6 pi. And 6 pi is my answer. The trick to that one is also you can see that only 1/3 of the curve will be finished in 2 pi. 1/3 in 2 pi, another third in 2 pi, another third in 2 pi. 6 pi. Hopefully you guys learned something from me today. Hopefully you didn't just copy what I gave you. If you like what you see, there'll be more videos coming. Hit the subscribe button. It's somewhere down there. I don't know where it is. Somewhere down there. Hit the subscribe button, and I will see you on the next video for the extended response.